Well, hi, good morning. Thank you so much for joining me in my shop here on November 2nd to face this radio once again. So I feel like I'm succeeding and failing at the same time with this radio. I seem to be figuring out bits and pieces of it, but at the same time, major chunks, just many question marks floating around in my head about what's going on with this radio. Maybe not many, maybe just a few really big ones. So, and here they are. Here's two of them anyway. Back to this capacitor up here. Still can't tell you what has happened here. Obviously it's been disconnected. Wires have been stripped out. So what happened? Where's the replacement for this? And I've been looking for this quietly and noisily and haven't found it. Haven't found any kind of replacement capacitors. So how can this radio operate without this capacitor in its proper place? There's actually two capacitors up here doing different jobs. One is quieting down the screen circuit in the radio for a couple of tubes, and the other one, I can't remember now. Bypass, I can't remember. Well, we're going to take a look at this. So my initial strategies, two strategies have both kind of flubbed. So I have a new strategy today. To sort this out, what I'm going to do is I'm going to identify the circuit to which this capacitor was connected. So in the case of the screen circuit, what I'm going to do is I'm going to identify the screen connection at one of the tubes, bearing in mind one of these tubes is different from what was in the schematic, and trace out the screen wiring path all the way to the power supply, and hopefully encounter the mysterious can't be found capacitor along the way, or prove that there's no capacitor, that this thing was cut out and abandoned and just forgotten about, and no replacement was ever installed for it, which is what it looks like. But you really got to ask yourself, how can this radio operate? Oh my god, I just remembered. Yeah, how can this radio operate but this capacitor disconnected? And what I just remembered is it's not operating. Right at the end of the last video, I turned it on, and very disappointedly, the radio did not appear to work. And I touched the grid cap here and got no response coming from the speaker. Okay, ignore everything I just said. That's what we really need to start off with. What has happened that has caused this radio to go quiet? And you know, touching this and hearing nothing, well, it suggests a tube failure is what it suggests. Yeah, how to approach this now? It's a good chance the trouble is in this tube. If it is a tube. Oh, there's a good chance of all kinds of things. You know what the biggest chance is right now? The chance of me going and drinking coffee before I really start into this. Yeah. Yeah, I'm already going backwards. That's what it feels like. Okay, so the two capacitors I'm trying to hunt down, the ones that are in the metal can, are these two here. One of them is tied to the screen line for these two tubes here. And the screen line's getting its supply from down here. The other one is connected between two resistors. This would be much easier to hunt down. A 2200 ohm resistor, coincidentally numbered R22, and R5, 30,000 ohm resistor. Previous looks at this have suggested to me both these resistors are missing, but we're going to look again. Okay, had to run and deal with my dishwasher there. Okay, if we follow this line, comes to the input side of the power supply filter here, input from the transformer, and there's C35 10 microfarads. We know where this one is. So we can go there and we can find this wire coming back this way. Let's go there. The other wire from this capacitor should be on the chassis. Let's start there and see if we can't start tracing this up to a 30,000 ohm resistor. Now if we look at the picture, here it is, 10 microfarads sitting here. One side is supposed to go to ground, isn't it? Interestingly enough, in this radio, I'm looking at it right now, one side does go straight to ground. There's a wire coming straight from here, straight to here. So this is already being done differently. Oh my gosh, coffee time already? This resistor, this terminal board, and this wire all missing. This connected differently. So one side is connected to ground, the other side is connected where? So this is I just have that feeling of spiraling down a toilet. Let's go take a look at this capacitor, find out where this other wire is going. Is it going to the rectifier? Rectifier. Filament, filament, plate, plate. Well, how's this getting its filament feed? This wire that appears to be just passing by, it actually is connected. This has to be connected, and this is the filament feed. Okay. So, well, this would be the takeoff from the rectifier for the positive side of the power supply. This would be the input filter. That makes sense. And this other leg is grounded. Well, that's exactly how it shows on the schematic. What's all this stuff? Because that is how it shows this on the schematic. Comes from the filament winding, capacitor, right to the chassis. So this is done as per the schematic, but nothing to do with that layout diagram. Okay, so we follow the wire onward into the radio, and the first thing you should do is go through a 30,000 ohm resistor and a substantial capacitor. This is really just part of the power supply filter, just stuck up here. That's kind of what that looks like to me. And then we're going through the coil, and we're going through to this grid here, which is going to act like a plate in this tube, like a plate halfway between the real plate and the cathode. So sure enough, it has the positive voltage on it. So we can work back this way and see where we end up relative to this point. So we're coming off the top of the capacitor, and I can tell you, I'm looking at it right now. There's a wire that heads for this coil. That's all. How's this wire going? What is going on? Okay, let's look at the radio a bit. All I can really promise today is confusion. I really don't have a good feeling about this. So here's the capacitor we're talking about down here. Here's a wire going right to the chassis, and the other wire's coming over here, picking up a terminal. It's a fat pin on the rectifier tube, so it's a filament, and also a wire leaving, this yellow one, which I installed. It goes up all the way up to the coil here in this electromagnetic coil here. Wire comes back. It's either the green one or the red one, and I don't know which one offhand it is. And that looks nothing like the layout diagram. So if we assume the layout diagram is where all the problems are, we just concentrate on the schematic. Maybe we can sort this out better. So is this wrong in comparison to the schematic? There's probably another wire there, and I'm not seeing it in the darkness. Yes, there is another wire. It's a twisted wire. It goes up into the transformer, so that's just the feed from the transformer. That's not going anywhere. The only wire that's going anywhere from this terminal of the input side of the pi filter of the power supply is the one that's going to the coil. There is no lead wire at all going. So that means, if we look at the schematic again here. So what it's saying is this wire doesn't exist. This doesn't exist. This has been removed, or we know the can sits there, but, and assumably this is gone, or this wire, like this has to be here. This wire has to get to a B plus supply somewhere down here. So we're going to trace back the other way now. I'm going to end up having trouble because it goes into this coil. L6 with a capacitor on one side of it, just going around to another coil. Okay, so maybe I can identify this fairly easily. We're going to trace the other way and see how does this screeny plate get its B plus, because not getting it this way. Okay, so I have to find this wire coming to this. Actually, this coil is really why I know where this coil is. So I really need to find this side of this coil where this capacitor is. C41. And if we look on the, close your eyes now. We shouldn't be looking at this diagram. It was what? What was the what? L what? L. It's L6 we're looking for. L6. L6 is here, and L6 is here. Okay. Yeah, no, don't look at the layout diagram. Run away from that. L6 is here. Okay, so we'll rely completely on this. So I'm going to find this point and this capacitor. That's what I looked at it for, to find C41. Where do they show C41 on here? C41, anybody see it? C41. A little hard to read these, they're small. C41. Basically between these two, 6 and 4. C41, 6 and 4, and tied to a trimmer. C41 between 6 and 4 and tied to a trimmer. Okay, so we'll look at the radio now. So here's a trimmer. I need that diagram right on the screen here because I can't do this like this. I can't go back and forth. If I had a piece of paper holding it here, it would be easier. I'm going to put it on the screen. Okay, here we go. Identifying this location here. L6. Here's the capacitor between two terminals on there. The capacitor connected between two terminals would amount to this one. It looks like it isn't, but it's actually tied to a wire which comes back to here. So these are the two terminals that the capacitor is bridging. These two. Okay, look back on that here. And that would be 4 and 6. So one end of it is going to 4, one end of it is going to 6. The tuning capacitor is on one end. So there's also, so here's a wire. Well, that's going over the band switch. It's a resistor. A resistor. A resistor. No resistor in here. Here. R22 2200, but this is orange. Orange is 3300. $3,300. That's the one that's identified with nowhere. Oh, I got so quiet so quickly. Just this little bit is blowing my head apart. Well, so we found this point. That's what's so important. And from here should be a resistor 2200. And that's what's there. And it's going over to the little board. Does that matter? It's going to the little board where you might find 4 microfarad capacitor. So there is a capacitor here, and there's something underneath it there, but would that be it? So that little board is shown on here, as untrustworthy as this is. Let's take a look at this thing here. Terminal board. So C24 looks like R10. I can't really read that. It looks like R10 and something 84. 24. C24. And this is R6 1.1 megohms. When I look at the only it's not connected like that. There's no wire here. Oh my God, this is different. Oh my God. Oh, you can see this. I forgot. Right. Okay. I'm going to turn this diagram the way it is. And let's see if I can find it back. Everything is different. So we're looking now at this little board. That's this guy here. So we see a resistor there. Now, maybe this resistor is the resistor that was there, and they moved it off the board out to the side, and then pulled this wire from this terminal over to here, and that would explain where this comes from. Not really, because this is going to this coil, and this resistor on the board is not. It's on a yellow wire going who knows where. Who knows where? Let's follow this yellow. Follow the yellow wire. Follow the yellow wire. Follow the yellow wire. Oh my gosh. Back of the volume control. Been down this. I think I followed this wire once before. Back of the volume control. Well, now the next approach, because this approach is just failing miserably. The next approach is for me to develop a schematic of, or there's two things here. Develop the schematic of the radio by looking at the parts and drawing it all out and sorting it all out and making my own diagram. And the heck with these two, the schematic and the layout diagram. I'll make my own diagram. Or abandon the whole thing. The whole attempt to understand what has happened in this radio. Replace the last few capacitors that are worthy of replacement, which I think I've actually done. I'm willing to bet this is a good capacitor. Now there's a whole bunch of these guys. There's one here, one here, one here, one here. these are pretty unusual capacitors. Why don't we take a close look? This one's right out in space. Let's take a close look at this. The question would be, are these also potential bad actors? I have little experience with them. You know what I can do here? Okay, if you just close your eyes for a minute, you won't see this transition. Well, that's actually better. I can't fix the radio, I can't work my cameras, I can't seem to do anything anymore. So I wanted to look at this capacitor up close. I think I'm going to have to fix the focus on the camera. We're going to get a real close look at it. I must do that. So once again, just hold the fort there for a moment while I bring up the dialog box and turn off autofocus and put this guy way up like that. Now we're going to take a look. So this is just as an example. So the lead wire coming in here, bare lead wire, and then we have a you know, this looks like two metal boxes, a small one inside a big one, and then there'd be some kind of insulation. That's literally what it looks like. It's more likely this is just like a bar or a rod going into the capacitor. This is clearly connected to this internal part. Now, is this the other end of it connected to the outside? I have to look at another one. Doesn't appear to be, does it? Appears to be also connected to the inside part, so maybe I don't understand the construction of these at all. Let's look at another one here. Look at this one. Oh. Well, that's a pretty darn complicated looking thing there. What is that? It's like maybe just the pieces of stranded wire happen to be sitting where they are. They look like they're going right into the capacitor. I don't believe that. Come over here. Oh my. Well, now what it looks like is a whole bunch of interleaved sheets, foils, interleaved like your fingers going together. You know how you can put your fingers together? And then they're boxed in with this metal cover, which is, well, I mean, like this is like a capacitor with no cover at all. I mean, even if the covered ones start having trouble, hey, what's happening to the end of that resistor? It's got like a little rubber cap on it. Okay, well, the construction's not what I thought at all. So this outside can part is probably just floating along here, doing nothing. Let's just see, get right down the back of it here. Okay, that's a lesson. So these are all going to be the same. Can I see the same sort of thing going on? Oh, it's even easier to see here. So a whole bunch of individual plates interwoven inside here. And then you can see on this the steel can part is just floating out here nowhere. This just doesn't seem like a very good way to make a capacitor, frankly. Especially since the outside can is just floating there. It's not grounded or anything. They're probably very easy to manufacture, and that's probably why they exist. And why they don't exist in great numbers. I've only encountered this kind of capacitor a few times. They look like they're all worthy of replacement. They do look like they're worthy of replacement. I mean, how can that be a good working capacitor? On the other hand, Jim, the radio does work. It's basically the same construction as a regular rolled up wax capacitor, but instead of a cardboard tube, it's a metal canny sort of thing on the outside. The moisture can go right into these things. They're not protected in the least. You have to remove one and test it. In fact, I could just disconnect the lead here, test this, see what we got in terms of, you know, how leaky is this and stuff like that, and then make a decision about changing them. It looks ugly, but let's do that. Forget everything I was doing. Let's get involved in something else. Maybe I can make some progress on. That's what I say. Okay, now if I nip this wire, I'll have to put an extension on to put it back into its place, but that's okay. Okay, what is the value of this supposed to be? I don't know if we know. Can we even know? Okay, so I'm going to bring some leads over here. I'm assuming this is a fairly... Yeah, I was going to say, I'm assuming... You know what? Let's test it with that little tester. That's what we should do here. And where is my little tester? Because if I bring leads over from the other capacitor tester I use, the leads will be long and they in themselves have their own capacitance. So if this were like a 0.01 or something like that, it wouldn't matter. But if this is a picofarad capacitor, and it could be, then the picofarads in the leads will start throwing the reading off. Let's see what we get with this. So we get, so 1300 picofarads is 0.0013. Now, can I possibly find this on the schematic in a trustworthy way? 0.001. Come on, let go. 0.001. Okay, so the schematic's right here. And the capacitor is running between, it's not shown here. This one's shown. Look at that. 13. Isn't that just what I just measured? It is. That's it. That's the capacitor. That's the capacitor. What's happened is, instead of installing it there, they've installed it on this side. Really? I don't know. That's what it looks like, though. So we have a reading that has matched something on the schematic. 1350 on the schematic. Let's do it again. It's a big deal. If I don't want to change parts I don't need to change. Every time I do some work on the radio, there's a chance I'm kind of messing it up rather than fixing it up. So less done the better. That's always been my point of view here. 1332, and it's supposed to be 1350. Oh my gosh. That's right on. It's kind of what I was suspicious of. Oddly enough. Even though you'd think, wow, these capacitors, I mean, they're just right out there. Okay, so I'll have to reconnect this. I'll have to put a little tiny piece of extension wire in there and reconnect it. Is there some reason, is there some advantage to having it disconnected right now in terms of testing? I don't think so. I don't think so. Okay, so I'm going to fit in a little extension wire here and put that back together. I think at this point I will conclude those capacitors are good because I have a test which shows them to be one of them to be good, and the radio operates. Well, it did operate. I forgot about that. I forgot again. This radio's not operating. Oh my gosh, I gotta make it operate. Okay, I'll put that back in, and we'll turn our attention to making the radio operate again. Oh my god. Okay, so at the end of the video yesterday, I couldn't get this radio to work, and I think I just discovered why, even now. Just getting ready to turn it on. You can see I have the antenna connected here. What I noticed in my newfangled antenna switching system here is I actually had the antenna switched off. I didn't have it switched on. So now it's switched on to here, which is coming over to the radio. How much you want to bet this time you turn it on, it works? Put your money down. Okay, I'm putting money down on this. I'm going to put some money down on this. So here's a Canadian toonie. It's a $2 coin, Canadian dollar coin. In case you're not familiar with American money, oh my god. Canadian money, that's a $1 coin. That's a loonie. That's a loonie because it has a picture of a loon on it. Can you kind of see him there? Loon. And if you have two loonies, you have a toonie. That's where we get our nicknames from. So, okay, so I'm putting down a whole dollar. Here it goes. How you're going to cash in on it, I don't know if I'm wrong. Volume down. Turn up just a little bit. There we go. Everything's ready. Everything is ready. Yep. 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 Will he lose his dollar? Or will, if I win, what do I should get my own dollar back? That's kind of a crummy deal. Okay, so I hear the thundering hum. Thundering because it's very low. Pulsing a little bit. Like a rumble. I don't hear any radio activity yet. I notice I don't have the antenna ground connected. That should put a stronger signal onto the antenna. Come on, man. Oh my gosh, it really isn't working. Oh, oh, oh. Oh, look at that. So you would expect changing bands would cause the radio to go click, click, click. You know, make noises. And you know, the real killer was I touched this. And we heard nothing whatsoever. Is there anything that I have let's see, smoke check there. The only thing I've done since the last time it worked was move this capacitor ground from here to here. It's the same thing. Definitely. Well, let's take out the signal tracer and what. So okay. So I guess I lost this. I'll just have to put it up here now. It's no longer mine. It belongs to you. You just come collect it. So I'm just going to do some signal tracing. But what's the use if there's nothing coming out of it here? Then we really need to look at a couple of tubes, I think, to start off with. A couple of tubes that maybe the detector tube and maybe the output tube have bit the dust during this process. Oh. Yeah, I don't know about that. Let's try a few more things first. Even more volume. Put the ground on. I'm hearing clicking. I'm going, what's that clicking? Oh, it's the wire banging here on the piece of wood. Nothing whatsoever. There's just nothing getting through this radio at all. And I could touch the grid of the output tube. You can see the heater on it. Let's try touching the grid. I'm going to grab just a voltmeter lead to an unconnected voltmeter. It's not even turned on. There should be enough hum in this wire that we can hear it. And so, which pin is the grid? Try to remember. Nobody home? Okay, I'm touching every pin on the output tube. This is the output tube. What I'm expecting is just noise. No B plus on the tube anymore. So what makes me so nervous about working on a radio like this is I think I know what I'm doing when I still haven't figured it out, but I don't know that I haven't figured it out. And next thing you know, I'm adding more problems to the radio without realizing it. So we want to look for B plus first off. Any B plus in this radio? I think it's up here. Okay, so we're on the dim bulbs. We're running at 92 volts input, 179 at the top here. Probably enough to operate the radio, but I think we're going to have to go full. Ooh. That's a really strong hum. Jimmy's worried. I'm worried. I'm pretty worried. Okay, so there's clearly B plus, roughly the right amount. Let's go back down. Okay, on the tube itself, B plus could be here. Could be here. So it's B plus on the tube. Tube appears to be okay, you know, as far as I can tell doing this kind of stuff. I think I have to put it in the tube tester because I'm sure I've touched the grid, and I would think absolutely noise has to come out of that speaker aside from the hum. Okay, let's do that. You don't want a failed 41. So these tubes are not as rare as I first thought. They are available. I'll be able to touch that. Not really. Okay, I'm going to give it a few minutes to cool off, and then I can handle it. We'll stick it in the tube tester and see what's happening. Okay, the lighting's a little weird, but it's the only way I can get this to show up on the camera. You see the pointer. So I've set this for 41. Let's double check before I plug this in. 41, 6.3 volts. 2 on the signal level, 46H for the bias setting, 73451, 73451, 6000, 6000, 20. It's so dark in here. 33. I didn't finish this. 33, and then we set this to F. 690 is the reject point, so just a little ways up around here. If it can't get above that, this tube tester is telling you to sell the guy a new tube. There we go. We're on. So I can see it heating up there. Always a good sign. Okay, the first test we'll do is are there any shorts between the tube elements? And I can't imagine there is, because I think something dramatic would happen in that radio. Passes the short test. We're going to push the transconductance test button, and we're going to look at it coming up just above where my thumb is. It's right there. Nothing wrong with this tube. This tube is not the cause of the problem in the radio. Almost certainly, the cause of the problem is me. I think, you know, if I had to guess, ooh, sorry about that. If I had to guess, I would guess me. right. A couple of these pins are a little fatter than the others, but not a lot right here. There we go. The other tube that's possibly causing trouble is this guy here. At the very least, we need to eliminate it as a problem. Come on. Whew. This is the 6K7, isn't it? See that it says 6K7. How sure am I that that's correct? Not so sure. This is not a 6K7. This is the detector mixer tube. Whatever that is. What is that? What is that? Just one second here. That tube is a... So I would never want to rely on my memory. It's a well, didn't they write it on here? They got second detector. Okay, yeah, okay, sorry, I'm expressing frustration. 6K7, 6A7. This should be a 6A7. There's no markings on it. We've got a radio that... Didn't I go through this already? This can't be the 6A7. Yes, it can. Oh my God, am I ever turned around? It's not the 6A7, for crying out loud. 6B7, yes. 6B7, okay, fine. I'll be okay. You know, it's a weird thing. I've been getting more sleep lately, like an extra hour and a half of sleep I've been sleeping in. And it seems like with the more sleep, my brain is foggier. Okay, I'll get this set up and away we go. Oh, bit of a surprise. This guy won't do a 6B7. It's 6B4 and 6B8, no 6B7. So, we'll try this other tube tester. We'll try this one. Now, this is my, what I would call, let me put it in here. This is the tube tester I use when I'm testing tubes in bulk, because this is the fastest tube tester going, and it does have a 6B7. I already looked. I'm just plugging it in here. This is a different style of tube tester from the other one. It looks similarly fancy, but in fact this is a much simpler tube tester. The test it does is simple on the tube. I cannot tell you the transconductance. So we have a 6B7. Now, just because I know myself, I'm just going to take a peek over here at the schematic. Yeah, 6B7. So I have 6B7 dialed up here. Show you how we set this one up. First you push these release buttons. Like if some of these buttons were down, push the release buttons. Pops up all the buttons along here. Now we depress the ones we want. 1, 2, 3 in the top row. 4, 5, 9. 4, 5, 9 in the bottom row. 65 on the big dial. 65. That's it. That's all the setting. Now we got to figure out how to plug this guy in. There's the two big pins because it's another. Which one do you want to go in? Which one do I want to go in? None of these. think it's this one. Okay, and it has a grid cap, so I have to put on this grid cap connector. Oh, jeepers, scared the bejesus out of me. Okay, I can switch this guy on. First, what's the heater voltage? I'm sure it should be 6.3. Yes, it is. So the meter automatically bops up to the middle and it's showing the line voltage right away. So you can do a line adjust here, but there's no need. It's close enough here. That's what's happening with this tester. When I go to do the test, the meter will then indicate the test result. You see, it just says good or bad, and it has a percentage. 100% is in the middle of the good. So can a bad tube show its badness by going way high? I think in some cases that's possible. Okay, so we're ready to do the test. First thing is we'll check for shorts. Short light is here. If it comes on and stays on, you know what? This is suggesting this tube is dead. This light should flash. Oh. Let's do the test. 6B7. You know what? I don't see the heater in it. How do we know this is a 6B7? Now I compared this. I held this up against one on the internet and it matched. So I'm really quite sure this is a 6B7. So hitting the button now. This actually does two tests. First test, WZ. This is for the amplifier. That when this tester does that, usually means the heater's not on. No heater. That'd be a dead tube. No heater. Okay, we'll do the other test anyway, just to show you. So what we do is we release the lower row. This is how they designed this. You can leave the upper row in place, and then you get a new bottom row. This time just 6. And now the test buttons are just X. And if there's no heat, this tube can't operate. But I'm just doing this kind of for fun. Pop it up. The other diode, push X. I think this tube failed right in the middle of us working on this radio. That's my impression. Any reason to doubt this tube test? Yeah, of course, I'm the guy doing it. Is there anything stupid going on here? 6B7, 1, 2, 3, 4, 5, 9, or 1, 2, 3, and 7. There's nothing funny going on. Push X. 65. This wouldn't make a tube show dead anyway. I think the tube failed. It's weird, but I think it did. That raises a good question. Do I have a 6B7 in the house here? So I put a 6B7 in here and test it in the tester. And that would test the tester to make sure the tester is telling the truth. But I think we have every indication in the world that this is the case. Right? I'm tapping the grid right, when it's in the radio, no sound coming out. Yeah, we tested the 41. 41 looks good. Testing the grid on this, no sound coming out. That's got to be the tube. There's lots of indications it's the tube, unfortunately. Okay, do I have a 6B7? Well, I'm going to find out now. So according to my records, I have one 6B7, but it's a Rogers coated tube. Just hang on here, I'm going to run and get a box of these tubes. Hold on. Of course, when I tell you to hold on, where are you going to go? You're sitting watching TV. So these are Rogers coated tubes. These are untested ones that I haven't put through the tester yet. And the thing about these tubes, this was a Rogers radio back in the day, thought they could get the jump on the tube manufacturing world by spraying on a metal coating on the outside of the tube. Then you don't need this. You don't need the shield. The shield is right on here. But then there's a problem of how do you make this shield connect into the radio? I mean, it's on the side of a glass tube with a plastic base. So if you look closely, there's a small wire kind of hanging out right here. And that's coming up from one of the pins and making contact with the shield coating. And that's a Rogers coated tubes. Now these, sometimes they have their own numbers. You know, there could be a 6B7 in here. This is a 6J8M. And the M denotes it's a Rogers coated tube. Of course, when you bought a Rogers radio, guess what it came with? These coated tubes. And when one of these tubes blew, guess what you had to do? You had to buy a Rogers tube to go in there, because they're the only guys making the coated tubes at that time. Something a little loose in this one. Is there a 6B7 in here by any wild chance? Because I have not gone through these or tested them or anything. See, there's that little metal piece sticking out there. I don't even know what that would be. Yeah, I don't know. The writing's all messed up here. And I don't have much faith that one of these is a 6B7. And I'm gonna have to look over these very carefully. So these are a little scarce. You know, they're made here, and they were. Oh, it's written up here, Jim. That's right. That's right. They write it up. 6K7. Okay, let's start again. 6K7. No. No, it's not written up there. Who's here? No answer. Is that you, Peanut? Is that you? Meowing at me? Wow. Yeah. This isn't going well. Hello. Here we are. This is another 6K7. So a 6K7 on the Rogers style. I'll tell you the difficulty with using these tubes. Oh, Peanut, really? Again, no label. This is not going to go well. Come on, any one of these. Show me a 6B7. Every one of these, the label is missing. Oh, it's up here. J8. And I think I have another box of these somewhere, which I need to scare up. This one, I can't read the label on this one either. Oh, no, it's on the top. Maybe it's been cleaned off the top in some cases. 6F6. 41. This is a 41. Rogers style 41. So what is the problem with just, if I have a 6B7, why can't I just pop it in there? First off, this can't be a 6B7. It's got to be a tube like this. It's got to have this kind of base, or it's not going in there. And it's 1, 2, 3, 4. It's 7 pins. 1, 2, 3, 4. So it's like this. You know, maybe this is one. Licensed by Thermionics Limited, patented in Canada 1922 to 1940. But they're not telling me what it is. Oh yes, they are up here. So this is a 6F7. Can you just hang on there a little bit there, Peanut? When I finish looking at these. 6B7. A 6B7. 6B7. Oh my gosh, we got one. Okay, and with the cap on the top. Oh. Not going to work. So what I have is I have another 100 or 200 tubes that I have not gone through, which are the older style tubes, which could very well be I have a 6B7 somewhere in my set. Somewhere. Yes. Okay. Take a look at this. We'll end the video with my cat trying to convince me to do something. What do you want, Peanut? Hey, Peanut. Hey, up here. He wants to go probably outside. What do you want to do? Do you want to go outside? Okay, here I go. If he goes up the stairs, he wants to go outside. Let's go find out. Okay. Okay, wait a minute. I'll be back. Okay, yeah, he definitely wants to go outside, so I gotta go deal with him. Okay, so I will spend my day hunting down another tube, and we you know, it's pretty conclusive. The tube failed in the middle of me working on this radio, but always a little room for a mistake being made, so I'll keep that in mind. Thanks a lot for watching. Quite the runaround from this radio. This was supposed to be a very simple, straightforward one. It's turned into one of the screwiest ones I've ever done. Okay, see ya.